Good morning.
Yeah, good
Good
morning.
morning. Good
Good.
morning. And thanks for the opportunity. May Allah continue to keep you alive and safe.
Yeah.
Please, I'm having a research on corrosion, and I've been thinking about how I can relate this machine learning to the process of that corrosion and some other part of it. The topic is basically assessment of rate of corrosion on quay walls and jetties. I've been trying to see some machine learning material as well so that I can support that research journey. So I've been trying to see if there's a way I can apply the machine learning process in the research. And that's my question, sir.
Okay, thank you very much, Mr. Ibrahim Akindele. You are highly welcome to the forum. And your question is very interesting, and it's something very possible. So when you have time, you can check out some of my profile. Personally, I've had projects in that area, corrosion prediction. Yeah. So this is some of the
Well,
preemptive system we do with corrosion prediction on oil installation and pipelines. You see, you don't wait, the corrosion. Corrosion is the only thing that is it can destroy the strongest of steel. Am I right? Within a short period of time. Once there is corrosion and you don't quickly resolve it or prevent it from extending, you finish off everything. So the importance of it cannot be overemphasized. So what you need is your data. Yeah. That you could be able to predict, okay, there is this particular place is going to subject to corrosion, because it doesn't just corrode overnight. It's a process, but we cannot see what is happening with our naked eye. Just take, for example, the case of what do you call it? Hurricane. We have several hurricanes in the
hello, sir. Please, I can't hear you. The network is bad.
Yeah. Okay. I hope I'm audible now. You can hear me now.
Yes, I can
Okay.
hear you.
Okay. Yeah. So I was saying that when corrosion takes place, it doesn't just happen one day or overnight. There are some processes that are already there that are gathering before finally it leads to that corrosion. To be able to drive it home, and I said when we used to have tsunami, before you can have hurricane or tsunami, there are a lot of things taking place under the ocean. Sometimes there's earthquake. But human being, we don't know. We cannot detect it. People may even be taking bath on the beach before, but there are some things already taking place there. Suddenly, by the time the effects start coming, then the whole place is engulfed, and then people lost their life. But now, because they started using data-driven decision making, they install some gadgets under the sea that are detecting whatever that is taking place there, and they are sending those data sets to the data center where machine learning algorithms are being used to crunch those data to analyze the data. The last time there was tsunami, when the characteristics that are similar to them, to that incident happened, machine learning will detect it. Oh, there's going to be a tsunami. It happened like 3 years ago in the US. 24 hours before, they raised alarm, there was alarm, there's going to be problem, there's going to be tsunami. They evacuated everybody, and no one lost their life. That is the kind of data-driven decision we are talking about. And the same thing goes to that corrosion you are mentioning. It doesn't just happen overnight. There are some characteristics that we look for, that you'll be able to get those data sets. When you have the data set, you analyze it. We train enough model maybe we are able to get like 1,000 samples. It's not easy. The material related data, sometimes we don't have data, but if you can get the data, even 500, even 200, whatever you have, we divide it into two. 700 for training, 300 for testing, for example, or 800 for training, 200 for testing. When you train, you know these samples. Sample 1, there is corrosion. Sample 2, there's corrosion. Sample 3, no corrosion. Sample 4, no corrosion. You look at some of the characteristics. This one had corrosion. This one doesn't have corrosion. This system try to understand which of this material will develop corrosion properties. Then we use the 300. We have the label. We know which one is corrode, which one is not. Then we'll be able to test. During testing, we don't give the output. During training, we give input and output for the system to understand characteristics of corrosion and those that do not suffer from corrosion. But during the testing, our 300 sample, we only give the input, the characteristics. We don't tell the computer the program already generated after training, because after training, you produce model, or what we call hypothesis function. Now, so during the testing, you need to test that hypothesis function, maybe it's working or not. We now pass this data inside this one by one. It tells us, oh, number 1, it's going to corrosion, no corrosion. Number 2, no corrosion. Number 3, no corrosion. Second one, number 5, corrode. So this is the prediction from our machine. Now we have the original result. We know the result. We now put it side by side. This is the original one. We now see that this is C, this is C, this is no corrosion, C. 1, 2, 3, 4, 5, 6. After 6, this is correct. This is a mistake. This one is wrong because it predicted that there is no corrosion. Meanwhile, there is corrosion. We see this is error. So if you have 5 out of 6 times 100, calculate the percentage. It's a very good system. So after using the 300 to check, maybe after 300, our model is able to recognize like maybe 280 out of 300 correctly. That is excellent when you calculate it. 280 divided by 300, you get the percentage accuracy. Another performance measure we can share. That means once you test it and you rely on it, we can build upon it. Your company says, I'm not comfortable with 280 out of 300. I want 100%. Then we do further algorithm inclusion, new hybrid, like I mentioned before. You can publish this one, and then you start to work on it. How can we make it better? I want to be able to get like 299 out of 300 correct. That is, every prediction, I have 299 out of 300 correct. That is almost 100%, 99 point something. We improve upon it. Then we can then deploy to real life to monitor our systems on the sea, especially installation on the sea. They are usually susceptible to corrosion easily, or where you have rain or some different type of environment that can cause corrosion. We now monitor our investment, and then we can alert before the corrosion starts fully. There is a process of corrosion like that, maybe 1 month, 2 weeks or more. You know better. But we want to start treating it before it degenerates to actual corrosion, which I call preemptive corrosion prevention, and also for that. So your project idea is a doable one and very interesting. Like I said, we did one before, 1 or 2, so you can do it. Learn basic of how machine learning can be trained and tested, and then you move on, you can have your work result. So I hope that clarifies. You need further clarification, like I said earlier, you can post questions to the forum. You can also contact us on private chat. Thank you.
Thank you so much. I'm grateful.
You are welcome, Mr. Ibrahim. Okay, so I believe those are the questions we have for the day. Thank you very much. Also, it is time, 2 minutes to go. Yeah. So thank you very much all for coming and for listening. The real request we make is invite your friends, let them also benefit from this our little community service, giving out to the people to learn this technology that is changing the world in a manner that we may not be able to understand the impact now. Yeah. So that is why the only thing you can do for us is tell people, let them know about it. A lot of people just joined recently, challenging me, Prof, we didn't know you have been doing this kind of training for people for free for a long time. I never hear about it. I said, I always ask people to please disseminate. Share it on your social media. Let people benefit. We have been on this since 2020. So God Almighty be the glory. So a lot of people from different parts of the world have benefited. And we are not stopping it by the grace of God. We continue. So please share the news. Let as many as possible benefit from this little efforts. So thank you all for listening, for attending, and wish you all the best. And looking forward to another edition. Leaving that, inshallah. Thank you very much. Have a nice day. Thank you.
Thanks so much, Paul, for the